Hi everyone! Today we're going to study line integral over plane curve. Given this illustration here, let C be a positively oriented, piecewise smooth, simple, closed curve, and let D be the region enclosed by the curve. Notice that a direction has been put on the curve. We will use the convention here that the curve C has a positive orientation if it is traced out in a counterclockwise direction. The curve is called smooth if it is continuous and differentiable. The smooth curve C is given by the parametric equations x equals h of t and y equals g of t. The parameter t is between the values a and b. The line integral of f of xy along the curve C is denoted by the integral of f of xy times ds, where ds is equal to the big square root of the square of the quantity dx over dt plus the square of the quantity dy over dt, and then the dt is here. To evaluate the line integral, we have to use the parametric equations. The line integral is now defined as the integral of f of xy times ds. Now, using the parametric equations, we have now this big formula. For example, compute the line integral. The integral of f of xy times ds, where curve C is given by x equals 3, y equals 90, for t is between the values 0 and 2, and f of xy equals x plus 2y. First, let us write our big formula. And then, step 1, let us evaluate this portion of the formula. That is the f of h of t, g of t. Let us write our function f of xy equals that x plus 2y. This f of xy is the f of h of t, g of t. And by these parametric equations, we can write f of 3, 90. So evaluating our f of xy with respect to 3, 9t, this becomes 3 plus 2 times the quantity 9t. Then we can simplify this further into 3 plus 18t. So this is our value for step 1. Next, let us evaluate this part of the formula for step 2. First, let us write the parametric equations x equals 3 and y equals 90. Let us evaluate first the dx over dt that is equal to 0. For dy over dt, it is equal to 9. Substituting these values in this formula, we have now the big square root of 0 square plus 9 square. And we can simplify this into 9. So this is the value of this portion of the formula. Step 3, let us substitute the values in the big formula. Upon substituting the values, the formula becomes like this. The definite integral from 0 to 2. It comes from these values of t. Then the 3 plus 18t comes from the result of step 1. Next is the number 9, which is the result of step 2. Let us copy this below our formula. Then let us start the simplification. We can simplify this further into moving the number 9 as constant outside the integral sign. Let us now integrate the quantity 3 plus 18t. We copy the number 9 down here, that is a constant. Integral of 3 is 3t plus integral of 18t is 18t squared all over 2. This fraction can be simplified into 9t squared. Distributing the constant, we have now 27t plus 81t squared. Now let us evaluate this with respect to the limits from 0 to 2. Evaluating now, we have this first group, 27 times 2 plus 81 times 2 squared, minus the second group, 27 times 0 plus 81 times 0 squared. For the second group, because of the zeros, we can cancel this out. We simplify the first group, 27 times 2 is 54, plus 81 times 2 squared becomes 324. The sum is the final answer, and that is 378. I hope you learned something from this video. See you again next time.